Hi everybody. Today we're going to talk about 8085 microprocessor control signals and data signals. So certain control signals are generated because of three control lines, and these control lines are input, output, memory bar, read bar and write bar. So we're going to study about this in the next slides. Now to understand about the generation of these control signals, first we have to be prepared to study ALE and RD bar. RD bar, write bar and input output memory bar. First with ALE, address latch enabler. It's kind of a device that is an active high signal and it is used to demultiplex the address lines that are AD0 and AD7 lines. So if the ALE is 1, that is if it is high, then we get address lines A0 to A7. And if ALE is 0, we get data lines D0, D7. So to differentiate between the data lines and address lines, and depending upon what to get, either it's the address lines or data lines, we can use this address latch enabler. After that, it's read bar, read data bar. It is active low signal. That means when it is active, when it is like low means low here means it is 0, then it is active. It will work when it's low. RD bar is 0, then microprocessor performs read operation. Similarly, write bar, it is also an active low signal. If write bar is 0, microprocessor performs write operation. Similarly, it's input or output memory bar. It is used to differentiate input, output and memory devices. If input output memory bar is 1, the input output operation will be performed, and if it is 0, then memory operation will be performed. S0 and S1 are status signals. So then, and these you can see on the left side, and these are the operations that we perform when we run a certain program, like opcode fetch operation is performed when we run a specific program, like memory write, memory read, memory write, input read, input write, interrupt, acknowledgement, halt, hold. These are all kinds of operations that are run when we run a specific program. So for an opcode fetch, input output memory bar is 0, and according to that, status signals are S1 and S0 are 1 1. That means that RD bar will go active low to have opcode fetch. And similarly, like memory read, for memory read, it's a memory operation, so input out of memory bar will be 0 to have this memory read operation. And according to S1 and S0 is 1 and 0, and read bar operation will be 0. And memory write, for memory write it's memory operation, so input out of memory bar is 0, and now S1 is 0 and S0 is 1. Then write bar operation will be performed. Then input output read operation is performed. That means input out memory bar is 1, and according to it S1 is 1, S0 is 0, and then read operation will be performed. And according to it, similarly input output read will be performed in this way. And then we go to interrupt acknowledgement. That is, in case of interrupt acknowledgement perform operation, input output memory bar is 1, and S1 is also 1 and S0 is also 1. In this case, int a, interrupt acknowledgement bar, is equal to 0. That means this will be performed. This will be active. For halt, input on memory operation is Z. Z is high impedance mode. That means halt will go to a high impedance mode. Z is denoted by impedance. And according to S1 is 0 0. But in the case of hold and reset is not valid. And according to it, it's read bar and write bar will be Z, and int acknowledgement bar will be 0. It's not visible here, but I'm telling you. Afterwards, we'll go with generation of these control signals. Well, there are three control lines. From these control lines, these certain four control signals are generated. Then these control signals are memory read operation, memory write operation, and input read operation and input write operation. Input write operation is not visible, but that's what it is. So we generate these control signals by the use of NAND gate. In the case of input auto memory bar, we take, like, we connect these and using these NOT gates, we develop input output operations, because this will go active for them. So like in this way, this whole circuit generates, we can generate control signals by the use of three control lines. After that, we can also generate these control signals using a decoder. See, in this we use a 3 by 8 decoder. In this type of decoder, we choose this 3 into 8 decoder because there are three control lines from which we'll generate the operations, like the memory read operation, memory write operations, input read operations, and input write operations. Then we'll interface the microprocessor with the decoder. Input auto memory will be input 1, read bar will be input 2, write bar will be input 3, and then we'll make the input line and we'll make the output lines as O0, O1, O2, O7. So then for these three inputs, we can generate a table to produce that output, and this will be as follows: 0 0 0 0 0 1 0 1 0 0 0 1 1 0 0 1 0 1 1 1 0 1 1 1. And we'll see that for memory read operation, input output memory bar will be 0. That's how a bar memory operation will be activated, because it's an active low signal. So for memory read signal, input auto memory bar is 0, and read bar and write bar, both of them cannot be same at the exact same time. So either one operation will be performed at a specific moment of time. Either read operation will be performed or either write operation will be performed. So in the first case, it's not valid. In the second case, read bar is 0 and write bar is 1. That means that read operation will be performed. And if input auto memory bar is 0, that means memory read operation. Similarly, we can get all the control signals from this. And moving on to the last one, we can see that input auto memory bar is 1. That means input auto operation will be performed. And similarly, read bar will be 0 in this case, and write bar is 1 in this case. That means that read operation will be performed. Accordingly, the control signal which is generated will be input output read bar. Similarly, we can understand how an input output read write operation will be generated. So in these two ways, we can generate these control signals for a microprocessor 8085. Thank you.